Today class for 10th class. In previous classes in chemistry we discussed about the reaction of acids with metal carbonates and metal hydrogen carbonates, and we also observed that whenever the acids reacts with metal carbonates and metal hydrogen carbonates, they commonly form salt, water and carbon dioxide. Next, today we are discussing about the important reaction is nothing but acid base neutralization reaction. Okay, today we are discussing about acid base neutralization reaction. So, to understand this acid base neutralization reaction, we can perform a simple activity. Take a small test tube and fill it with 2 ml of sodium hydroxide solution. Means nothing but NaOH solution. First you take a small test tube and take approximately 2 ml of sodium hydroxide solution. Then add few drops of phenolphthalein indicator and observe the color change in the test tube. We observe that when we add some drops of phenolphthalein solution in the test tube that contains sodium hydroxide, immediately the solution color changes to pink. Immediately the solution color changes to the pink. Then add some amount of hydrochloric acid solution in the test tube and carefully observe the color change in the test tube. In this case, we observe that the solution color becomes colorless, but nothing but the solution appears as colorless solution. So, while in the first we observe that when we add phenolphthalein indicator to the NaOH solution, it will become as pink. But when we add HCl to this solution, immediately the solution becomes colorless. Again, add some drops of NaOH solution. What we observe, again the pink color reappears. So, what is the reason behind? So, let us understand the chemical reaction in between the sodium hydroxide base and the hydrochloric acid solution. So, in this reaction, we observe that sodium hydroxide, take what? Sodium hydroxide plus what we take hydrochloric acid. Hydrochloric acid. So, the sodium hydroxide formula is NaOH plus hydrochloric acid formula is HCl. So, we observe that this sodium hydroxide reacts with sodium hydroxide reacts with the HCl and forms the products nothing but here we observe that one NaCl and water. NaCl nothing but sodium chloride, H2O nothing but water. Means nothing but salt is formed and water is formed. So sodium hydroxide is one of the base, HCl is one of the acid and forms salt, sodium chloride and water. Let us observe the another reaction. So in this case, take the base KOH. means nothing but potassium hydroxide, and add HCl solution to this one. In this case also we observe that the salt is nothing but KCl. KCl is forming, and we also observe that water is formed. What? Water is forming. So the formula of this salt is nothing but KCl2. So for the balancing we write 2. Okay, sorry, 2. In this case we observe that the salt KCl2 forming and H2O also forming. So this is also one of the example for the acid base neutralization reaction. So in the first one we observed sodium hydroxide. Here we observed that one hydrochloric acid. Salt is sodium chloride and H2O. So here what we observe, KOH plus 2 HCl is equal to KCl2 plus H2O. So in this case we observe that one anyone. So finally we observe what? One of the salt and water. What is acid base neutralization reaction is nothing but when acid reacts with base and forms the salt and water. This chemical reaction is acid base neutralization reaction. Okay, when one of the acid and base react with each other and finally form the salt and water, that is called as acid base neutralization reaction. Next reaction is nothing but reaction of acids with metal oxide. Reaction of acids with metal oxide. So here acids example take HCl and metal oxide you have to take the CuO, nothing but copper oxide. In this case you observe that the metal oxide, copper oxide reacts with the HCl and forms the salt, copper chloride and water. So we can write in the equation form CuO plus HCl and forms CuCl2 plus H2O. CuCl2 plus H2O. So CuO nothing but copper oxide, hydrochloric acid, copper chloride and water. Here acid, it is salt and water. So the reaction of acid with metal oxide reaction are also similar as acid base neutralization reaction. So how we test nothing but normally whatever it may be, the solution is formed copper chloride. Dip the blue litmus paper, immediately observe the color change, and dip the red litmus paper and observe the immediate color change. We observe that the red litmus paper color changes to blue. Nothing but this copper oxide, nothing but metal oxide. It is in basic in nature. Why? Because nothing but it turns the red litmus paper color into blue. So here reaction of acid with metal oxide, we observe that when the metal oxide reacts with any acid, forms same salt and water. This reaction also similar as the neutralization reaction of acid and bases. When you test the salt with the red litmus paper, immediately the red litmus paper changes to blue. It confirms that metal oxides are basic in nature. What? Basic in nature. Next reaction, observe the reaction of bases with non-metal oxide. Non-metal oxides. Okay. Reaction of bases with non-metal oxides. So, base. You have to take that calcium hydroxide is one of the base. And non-metal oxide. You know that one. Non-metal is nothing but carbon, its oxide is nothing but CO2. So here the calcium hydroxide is nothing but base. It is non-metal oxide. This calcium hydroxide base reacts with the non-metal hydroxide and forms the calcium carbonate salt, and we observed that water. So this is salt and water. This reaction of bases with non-metal oxide also similar as acid-base neutralization reaction. So here also when you test the salt with the blue litmus paper, immediately the blue litmus paper changes to the red. So nothing but non-metal oxides. These non-metal oxides are acidic in nature. From this experiment, we can say that one non-metal oxides are acidic in nature. So this is about the reaction of bases with the non-metal oxide. Next topic we are discussing is nothing but electric conductivity of acids. Next topic is what? Electric conductivity of acids. What is the aim? To show that acids conducts the electricity, or to prove that acids conducts the electricity. What is the aim? To prove that acids conduct the electricity. Material required: beaker, diluted hydrochloric acid solution, graphite rods. Next, electric wires, 230 volt AC plug. What? 230 volt AC plug. Next, bulb. These are the material required to perform this experiment. What? One large size beaker, diluted hydrochloric acid solution, graphite rods, electric wires, 230 volt AC plug, bulb. Procedure: first take beaker and fill the beaker with some amount of diluted hydrochloric acid solution. Next, place 2 graphite electrodes in the acid solution. Place 2 graphite electrodes in acid solution. Connect one of the graphite to the 230 volt AC plug. Next, connect the another graphite to electric bulb. Next, complete this circuit by using the electric wire. Next, now pass the electricity through the acid solution and observe the bulb carefully. We observe that the bulb will bright or glow very brightly. Why? Because nothing but whatever it may be, pass the electricity that flows through the acid solution and it leads to the glowing of bulb. So, from this activity, we prove that acid conducts electricity. How does acids conduct electricity? Here, in between the two graphite rods, gap is there. Nothing but we pour the acid solution. So, this HCl, when we pass the electricity, the HCl solution dissociates into H plus ions and Cl minus ions. When we pass the electricity, the hydrochloric acid solution dissociates into H plus ion and Cl minus ion, and the H plus ions which were produced in the solution are responsible for the conduction of electricity of acids. Okay, when we pass the electricity, at the time the hydrochloric acid solution is dissociated into H plus ions and Cl minus ions. These hydrogen ions are responsible for the conduction of electricity of acid. Okay, once again, activity aim to prove that or to show that acids conduct the electricity. Material required: 1 large size beaker, hydrochloric acid solution, graphite rods, electric wires, 230 volt AC plug, bulb. Procedure: first you take 1 large size beaker and fill the beaker with some amount of diluted hydrochloric acid solution. Now insert or place 2 graphite electrodes in the beaker. Connect one of the graphite electrodes to the 230 volt AC plug. Connect the other graphite rod to the electric bulb and complete the circuit by using the electric wires. Now pass the electricity through the acid solution and observe whether the bulb is glowing or not. Result: we observe that the bulb glows brightly. Why? Because whenever we pass the electricity through the acid solution, at the time the hydrochloric acid solution dissociates into hydrogen ions and chloride ions. The H plus ions are hydrogen ions are responsible for the conduction of electricity through the acid solution.